guys, how are you doing? Today we're going to talk about moles again and how you can get to volume. So we had already talked about that we said moles are the heart of chemistry, right? And we said that you can go from moles to particles of any substance using that 1 mole is equal to 6.022 times 10 to the 23rd particles. We also had talked about going from moles to the mass, or grams, using the molar mass from the periodic table. Today, we're going to talk about how you can go from moles to volume. This only applies, though, if it's a gas, and only at something called STP. So let's talk about what STP is. STP is standard temperature and pressure. And standard temperature is 0 Celsius, which is 273 Kelvin. Standard pressure, we haven't really talked about pressure. We're going to learn about that in chapter 13 when we get to gases. But pressure is force over area, and standard pressure is 1 atmosphere, or 101.3 kilopascals, or 760 millimeters of mercury. Now, to be honest with you, for the quiz that we're going to take in this chapter, you don't really need to know this. For the test, you do need to know these numbers, but it's going to be one multiple choice question. So I know that we haven't really talked about pressure units yet and what this means, but for now you just need to know these numbers, what standard temperature and pressure is, what standard temperature is, and what standard pressure is. But anyway, it turns out that no matter what type of gas you have, whether you have helium or sulfur hexafluoride or carbon dioxide, any gas, 1 mole of that gas at standard temperature and pressure will be 22.4 liters. This is something that Avogadro came up with. Remember, he did not come up with that 6.022 times 10 to the 23rd number, but they wanted to honor him. And one of the things that he came up with is that any gas, no matter what type of gas it is, 1 mole of it will occupy 22.4 liters at STP. I want to show you what 22.4 liters looks like. This box has a volume of 22.4 liters. And it doesn't look like a lot, but 22.4 liters, you know, we're kind of used to gallons and quarts and stuff like that. Soda comes in 2-liter bottles, right? So you can actually fit a little bit over 11 2-liter sodas in this box, just slightly over 22 liters. So this is 22.4 liters. This is how much the volume of 1 mole of a gas is at STP. That's a number that you need to memorize or know. So we're going to add to our chart here that 1 mole is equal to 22.4 liters. This applies to any gas as long as it's STP. So let's see if we can do some problems here from worksheet 3. So flip to worksheet 3. And I believe this is number 1. Let me use a different color here. This is number 1. So it says, how many moles of water vapor occupy 39.5 liters at STP? So we're going to write down what we have first. 39.5 liters of water vapor, which is H2O. And we're going to start our conversion factor. And on the bottom, we want to put liters of H2O so they cancel. On top, we want to put the units that we are looking for. We are looking for moles of H2O. Can we go from volume, or given volume, to moles of the same substance if it's a gas at STP? Yes, we can. 1 mole is equal to 22.4 liters. So we can go ahead and go to moles of H2O. Like I said, I always go with my units first, put them in first, then my numbers. So again, 1 mole is 22.4 liters, so we're going to put 1 next to the mole and 22.4 liters next to the liters. So liters cancel, and you do 39.5 divided by 22.4. We want 366 for our answer. It ends up being 1.76 moles of H2O. Let's try number 4. So, number 4 on worksheet 3. What is the volume of 2.53 moles of HCl gas at STP? So we're going to write down what we have, 2.53 moles of HCl. We're going to start a conversion factor. On the bottom, we're going to put the same units so they cancel. And on top, we would like to put the units we're looking for, which are volume, so liters of HCl. So I'm given moles. I'm looking for liters. Can I go from moles to liters of the same substance right away? Yes, I can. 1 mole is 22.4 liters. So I can go ahead and put liters of HCl here. I can link between them. 1 mole is 22.4 liters. Moles cancel. You do 2.53 times 22.4 and you get 56.7 liters as your answer. So notice how here the 1 mole is on top and the 22.4 liters is at the bottom. Here the 22.4 liters is on top and the 1 mole is at the bottom. What decides that is what units you're given and what you're trying to find. So at the bottom you always write the units that you're given. On top you write the units that you're trying to get to. Let's try another problem. Let's try number 10 next. What is the volume of 10.9 grams of hydrofluoric acid gas at STP? So I'm going to write down what I have, 10.9 grams. Hydrofluoric acid is HF. Start a conversion factor. On the bottom, I'm going to put grams of HF. On top, I'm looking for volume. So can I go from grams to volume right away? Well, let's check in our chart here. We are given grams. We're looking for volume. Can I go directly? No, I cannot. I have to stop by moles first. So I need to go from grams to moles first using my molar mass. And then I go from moles to volume using 1 mole is 22.4 liters. So again, my first step is going from grams to moles using the molar mass. So let's do that first. So grams to moles, and I use my molar mass, 1 mole. To get my molar mass, I add up a hydrogen and a fluorine together, and that's about 20.0 grams. And that gets rid of my grams, so now I am at moles. So my second step here, now that I'm at moles, I can go now to volume using 1 mole is 22.4 liters. So I'm going to do another conversion factor. On the bottom, I'm going to put moles of HF so they cancel, liters of HF because that's what I'm looking for, and we said 1 mole is 22.4 liters. My moles cancel. So in your calculator, you want to do 10.9 divided by 20 times 22.4, and this gives you 12.2 liters of HF. Okay, finally, let's do number 12. How many molecules of sulfur dioxide gas occupy 0.342 liters at STP? So let's write down what we have. So I have 0.342 liters of sulfur dioxide, SO2. And on the bottom, I'm going to put liters of SO2. I am given volume, right, the liters. I'm trying to find molecules. Which one is molecules? So I'm given liters, I'm given the volume. I'm looking for molecules. Molecules are particles, right? Formula units, atoms, and molecules are particles. Can I go from volume to particles right away? No, I cannot, but I can go through the moles. So my first step would be going from volume to moles using 1 mole is 22.4 liters. Once I get to moles, then I can go from moles to particles using 1 mole is 6.022 times 10 to the 23rd particles. So my first step again, going from volume to moles using 1 mole is 22.4 liters. So let's do that first. So liters on the bottom, moles on top. And 1 mole of a gas is 22.4 liters of that gas. Liters cancel, I'm at moles now. So now I can go from moles of SO2 on the bottom to cancel to molecules of SO2 on top. And to go from moles to particles, 1 mole is 6.022 times 10 to the 23rd molecules or particles. My moles will cancel. So I take 0.342 divided by 22.4 times 6.022 times 10 to the 23rd, and I multiply them all together. I get 9.19 times 10 to the 21st molecules of SO2. And that's my answer.